Katie Zaccardo with ABB's Wind Power Team. I will be moderating today's webinar. Before we get started, I wanted to go over a few housekeeping items. All participant audio will be muted during the event. If you would like to ask a question during the event, please use the question box on the GoToWebinar panel. We will answer as many questions as possible at the end of the event. Please ask your question during the presentation so it will be available at the end. Today's webinar is being recorded. A link to the recording will be emailed to you following the event. Feel free to forward the link to people you know who could benefit from the presentation. Now, to introduce our speakers. Mr. Dennis McKinley is the Director of the Wind Power Initiative in North America for ABB. And also, we have Adrian Timbus, who is a Program and Product Manager for Wind Automation at ABB. Dennis McKinley would like to open today's webinar with a few words about the wind power industry.
Thank you, Katie, and thank you for all you folks out there that have dialed in to attend the webinar today. Appreciate that. After working in the wind industry for a few years, we came up with a visual referred to as the wind farm value chain, which includes some of the key areas of focus for wind farm development. Based on a lot of discussions and feedback in the industry, we decided to host a 4-part webinar series on it. We have already completed planning, collecting, and connecting, and today is our last webinar in the series on operating and maintaining. We hope you get a lot out of these webinars. Based on the feedback we received so far, they've been very well done and a lot of positive feedback to us from that, so I appreciate that. If there are other topics that you're interested in hearing more from us about, please let us know, and there'll be ways that you can do that at the end of the webinar. Next. So ABB has been supporting this industry for over 30 years. The landscape drawing you're looking at now highlights some of the areas that ABB provides products and services today. Everything from early planning on the wind farms to the major electrical equipment inside the wind turbines, including generators, converters, possibly transformers, low voltage products, and then to the electrical balance of plant on the ground or in the water, helping the owners tie in vast amounts of wind converted to power into the grid on a global basis. Next. So our goal in today's webinar is to show some of the tools that exist today that can help you operate and maintain your wind farms for optimum performance and get some of the best yields out of the wind to drive generation and revenues. With that said, I'd like to turn it over to Adrian Timbus, who will walk us through this section of the wind farm value chain. Take it away, Adrian.
Thank you, Dennis. So today's topic, it is about operating and maintaining wind power, and we will be looking at one of the key systems and its functions for doing that. This webinar is a part of a series, as Dennis mentioned, related to wind power. However, today I would like to use a more generic term of renewables, just to show out that what we are discussing here today also apply to other generation facilities such as solar or small hydro plants or geothermal plants. Due to the fact that renewables are let's say, it's smaller capacity plants as compared to the traditional power plants, and they are usually unmanned, so everything is fully automated into the plant and geographically dispersed. One of the effective way to manage this plant is to use remote management centers or remote control centers. These centers are used to get all the data from the plants, analyze the data, and store it for long-term decision making, and then of course enable the operators to react to any event that is happening into the plant. We will firstly look today at the architecture of this system, and then try to see some of the key functionality of it, and then see how this what sort of interfaces this system has with other systems relevant for effective operations of renewable plants. We will discuss the interfaces with the grid operators and market operators, or the ISOs, and also with the service and maintenance centers. And then we will go a little bit more deeper in the functionality and functions of the system, and we will be looking at monitoring and diagnostics of a fleet of plants, and the energy management functionality and the role of it to turn renewables into a reliable generation resources. And at the end, we will also look into forecasting and the role of power production forecasting for in managing the renewable plants. So on the next slide, we see the architecture of such a system. Now, typically, this is a multi-level automation solution, and everything starts really at the plant level, where we have a management system for the plant. This is typically composed of a SCADA part and a control part. Right? The SCADA is mainly in charge with gathering the data and storage, local storage, and some sort of analysis locally there, but also really integration of all information into a single system. Because if we look at the chain of building up these plants, we have, if we take the example of a wind farm, then we have the wind turbine OEMs coming up with the turbines and with the control system for those turbines, such that the plant behaves as one generator only, and then a SCADA system associated to that, to the generation part, to the turbines themselves, for storing the data coming from each individual turbine. On the other hand, we have the balance of system or the balance of plant, which is the electrical system interconnecting the generation part with the grid, typically a substation there, and the substation provider comes again with another separated SCADA system with automation system and so on. And a plant management system needs to have all this integrated and needs to aggregate the data and made it or prepare it to be sent out to a remote management system. At the remote level, it is typically, it's not simply just data aggregation and data gathering. Really the value added of this system here, it sits into the function that it can have, the features of it. And we will discuss some of them later on. But some of the main points will be here, the greater awareness for the operators and then effectiveness of their operations. And then we will, as I said before, we will look in some of the functionality of it for energy management particularly. There is typically, and this is more typical for very large utilities, that they use yet another layer of data aggregation, and this is really sort of data warehouse, when they really store all the information from all their assets they have. And we can imagine that some of the utilities really play into a global market, particularly when it comes to wind and to other renewables. Now solar is coming up there as well. So this global management center really pulls the data from a few, depending on the utility size, remote centers located in different continents, right? And this is the system where data is further analyzed for long-term strategy definitions and financial calculations and investment analysis and so on. Moving on next, we will focus on the monitoring and diagnostics of the monitoring and diagnostic functionality of the system. Next slide, please. And here we see that basically everything begins at the plant level. The plant, they provide the data up, and the remote control center pulls all the plant data, alarms, notifications, and so on. And when it comes to the specific of a wind turbine, what we see up there in the field, usually a wind turbine broadcasts something between 200 and 400, typically 200 to 400 data points. But we also see some of the OEMs broadcasting much more than that, with some cases of 800 data points per turbine. So imagine that there are hundreds, or even a utility having thousands of wind turbines. It means we are dealing here with a large amount of data coming up into this remote management system. That means the SCADA system has to be flexible, has to be scalable, and has to be also really fast to cope with the real-time specifics and the dynamics in this in the data that is coming up into the system. Because, as I said before, the plants can be located across the geography, and then as the power production, it is directly influenced by the weather conditions. That means the data is changing fairly constant into the system, and all these changes are reflected up in the remote control center, such that operators are able to react to those. In addition, that there is a large number of plants, there is also the fact that these plants are fairly different one from another. There is, most of utilities have in their portfolio, if we take again the example of the wind, they have wind turbines from different OEMs. And what we see that these OEMs, they are sending this data in a different way. Each of them are having a set of signals to be sent out, but at the remote control center, this needs somehow to be flattened out, to create a common information model for all of the turbines, such that the operators working with the system should not try to learn, okay, this is a turbine from a particular OEM, this is a turbine from another OEM, and so on. They should be exposed to one common interface, being based on a common information model where, of course, this model should cover all the aspects of each individual turbine out there in the field. Once we have the data out there, right, this is a large amount of data. This needs to be further analyzed. This needs to, some sort of intelligence has to be taken out of that. It's because the turbines themselves may send out analog values or even digital values, alarms and status and so on, but there is a need of having a layer of applications to understand why it's happening this, what does it mean, and so on. And usually there are some diagnostics tools present at the control center out there to make easier the life of the operators to working with the system. And of course, the results of these diagnostic tools here are made available then to other systems, such as service and maintenance, such as energy management system, or asset management and workforce scheduling. Depending on what sort of information is necessary, we will go a little bit more in details later on, but we'll see that other functions, other systems within this need the information from the plant to further improve the operations and further improve the reaction of the operators to what is happening in the field. So on the next slide, let us go a little bit more in details and look at some of the functions of the remote management system here. And we talk first about the effectiveness of the operators. I mean, coming out from thermal or, let's say, conventional generation, usually in any other system, if you want to manage that in an effective way, then a lot of an alarming system is put in place to make the operators aware that something is changing in the plant, something has changed, something has happened in the plant, right? And again, we look here at the particularities of renewables and distribution across geographies and variability with weather conditions in different parts of the world. We see that the alarm management system has to evolve in a way that it has to be more intuitive. It has to provide information at a glance to the operator to be able to react better, to be able to see faster what is happening out there. There is a trend to use geographical information system, the GIS, combined with alarming, so displaying of alarms into the GIS systems, and have really fast navigations from high-level display maps into the plant, into the component or asset issuing that alarm. According to some of the customers, what we see out there in the field is that about 30% of the alarms can be cleared from the remote monitoring center, meaning that effectiveness can be improved through such an action. Moving on next,
Adrian?
it is.
There's some feedback coming from some of the folks attending that they can't hear you that clearly. So if possible, could you get closer to the speaker and speak up a little bit, please?
Okay, thanks, Dennis. I'll try to do it a bit better. So on slide 11 here we have a greater awareness. This is another feature of the system. It is information at the glance, and put up there, and the information displays have to evolve into something more structured, more informing to the operators, such that they can take the right decisions by just simply looking at the display and do what they're supposed to do. Like we have here in this figure, there is a representation of a wind farm, and immediately you see the number of turbines out there. You see marked with the green the turbines that they are running and operating. There are 2 turbines marked with red, meaning they are alarms and they are stopped. And then we see 2 of the turbines with yellow, which means they are in maintenance state. Right? And on the sidebar, there are some values. They cannot be seen here in the picture, but there are some aggregated values for the plant itself. So with this type of representation, an operator can see immediately, okay, I have to have my assets down, I need to react on that, I have to check those alerts, and so on. On the next slide, we have again the feature of the system to be able, or to allow operators really to react to what is happening in the plant. And this can be done through remote management, to real-time, a connection between the remote system and the plant system itself, and be able to control the equipment from remote centers, being able to set points for operating of different turbines, and handling of errors or any other issues that they are out there in the plant. Moving on next, another key features of the monitoring system, it is data analysis. I mentioned it before, a layer of diagnostics is necessary to make more out of the data that is sitting in the database. And really here, the key performance indicators, and it is the state of the art today. Now, small algorithms to analyze the data, to identify the performance of each individual turbine, to identify its efficiency and how it runs according to the weather conditions and so on. This type of small analysis tools, it's available today in such systems. The IEC 61400-12, it is the standard that defines how to measure performance of wind turbines, and typically most of the systems support this. Of course, customers, they have their own performance indicators when the power production and then the incentives for power production are measured based also on the grid quality and so on, that we see a lot of requests there to really decouple the operation of the plant from the conditions of the grid and check out when the grid was there, was present, and had the right quality for the operations, and in case the plant was disconnected, to find out really the reason why the plant was disconnected. Was it because of the assets within the plant, or was it because of the grid conditions they had at a certain point in time? Moving on, let's discuss a little bit about the energy management. As I said before, this is one of the key functions to turn renewables into a reliable generation asset. And we know that you may be familiar that to connect the generation facility to the grid, it has to comply with the grid codes. Right? And these grid codes today, they are specific to the country, to the region, or even to the TSO. Right? And that they are also fairly often updated. But the main trend is what we see out there is that the grid codes are trying to request renewable plants to provide the same or similar functionality as the traditional power plant. That means that a sort of, not only that we aggregate all the data out there, and then we try to manage it in a way, or we try to manage the plants in a way to be more effective, but now we have to also provide a functionality for managing the power such that the plants themselves are complying with what the TSOs, ISOs are requesting in different grids, or in some cases within the same grid managed by only one operator. And energy management function, it is one of these functions to help renewables complying with grid codes and to facilitate the integration of renewables into the mechanism for running the grids and for running the markets. So as we see here on this slide, we have the interfaces between the energy management system and the ISOs, right? And here it is where the scheduling of power production is exchanged between the generation management system and the ISO and grid management system. But of course, to be able to form sort of an idea of how much power can be generated and how the requirements from the grid operators or the market operators can be fulfilled, then the energy management system needs information from the plants themselves, needs to have connection to the real-time monitoring and diagnostic functionality and get the latest updates about the status of the assets out there to find out how much power can be produced based on what assets. And of course, we will discuss a little bit later on how, when we come to forecasting functionality, but if you want, the market mechanism, usually it's a day-ahead mechanism, and we have some activities also in intraday, which means that not only real-time information from the plants is necessary, but the system also needs to know what is the capability of the plant to produce power next day. And for this, forecasting or power forecasting functionality, it is very relevant. We will come back to this functionality in a couple of slides later on. Now, when we look a little bit more deeper into the energy management system, then we see three key functions here. One is the automatic generation control, which basically controls the power generated by all the plants, right? And distributes the set points of the plants according to the agreement that it has been done with the grid operator or with the ISO. On the other hand, we have the automatic voltage control, which controls the voltage at the connection point between each of the plants and the grid, right? And both of these systems are, or both of these functions are more or less relevant more for the grid operators and the market operators rather than from the power producer itself, right? Because they are providing a functionality which helps, of course, integration into power grid, has helped the management of the power grid. But for the generation company, it is more interesting to look at how do I dispatch my plants such that I achieve the same agreement that I have with the ISO or with the TSO without getting over what was planned with them, but do a more intelligent dispatching on my plants. And again here, real-time information for the plant is a key, plays a key role together with the energy management to really find the best optimal way to dispatch the plants. Moving on next, it is forecasting of power production, and we said already this is a key function for operations and planning. Of course, knowing what will be, or how much can I produce next, it's something that many other functions or systems could use in a way or another. As I said before, used by the energy management system just to make the agreements with the TSO and ISO. But if we look here, there are other systems around that could use that they could use information from the forecast. Workforce management or service maintenance is just helping to make a proper planning to find out when the production is lower, when the weather conditions are not favorable for production, and really schedule the maintenance of the plant in that time. Of course, it has also some links with asset management and make the order of spare parts, but probably this is already on a longer term, and connection with the energy management system I already mentioned. Now, of course, power production, it's something today which is very interesting, and then it is really driven by how the market operates and it's structured today. But what we see also as a trend is to push more and more renewables to participate in the market mechanism rather than being still based on the incentives or on subsidized programs such as power purchasing agreements or feed-in tariffs. Right? And in the case when a utility, a power producer, decides to go on the market with his renewable fleet, then it's also very interesting to forecast the prices of the market, right? Because then you might have the freedom to not produce when the prices are low, but produce when the prices are high. And here it's again a very tight link between the energy management and the forecasting of now both power production and the energy prices. This could lead again maybe better invest into storing energy rather than selling energy for free or even with negative prices in some cases. We will come back later with an example on this in one of the projects to show at the end. Moving on next, then let us discuss a little bit the relevance to the generation management, because I mentioned before it spans across some time scales, and we have management at the real time, really at every second control the generation of every single plant out there, and this is what automatic generation control and automatic voltage control really do. And of course, these are also related to the grid operations. They are done today. Plants are monitored and the production is monitored, and whenever there is discrepancy between what has been agreed or what was planned and what is the real effect coming from the plants, then it's covered by the reserves. But there is also the aspect of intraday and find out how much production can be realized for that day or for day ahead. And this is it is fairly relevant for the energy market, particularly when decide to put or to sell your energy into the energy market. Very good forecasting solutions for day ahead market will be very relevant here for day ahead planning. Of course, then if we look at, there are also, apart from the energy market, there are also ancillary services market there, and usually these are required in many areas to commit for 1 week ahead. I mean, we know that predicting weather for 1 week ahead it's fairly unsecure, but predicting power based on weather conditions on that comes also with great risk. So there is need for improving this functionality of forecasting for longer term forecasts to be able to participate in this ancillary market, or at least really to minimize the risk when participating in this ancillary market with renewable energy. Of course, the result or the error induced by the forecasting functionality can also be covered, for instance, by an energy storage or by another type of or more controlled power plant, a hydropower plant, or even a geothermal plant. Of course, long-term forecast, I mean, they had up to 1 week ahead. It's also becoming relevant for the service activities, and for planning of maintenance activities and for workforce scheduling. And then therefore, forecasting is becoming one of the key functionality to interfere with the rest of the system and make really renewables being more trustable, being a generation resource that could at one point in time replace the traditional thermal generation. Moving on next, then we will have a look at applicability of these functions in real life, and we go through over some reference projects here, just to give you a hint of how this is used by different utilities in different parts of the world. We have here an example of an installation in Italy, where basically there are 6 remote control centers distributed on regional or macro-regional basis here. And these 6 remote control centers monitor around 500 plants. There are around 1.5 megawatts of hydropower, and then we have 700 megawatts of 720 megawatts of wind power. Then we have more or less the same amount of geothermal power and a small amount of PV plants in there. In addition to these plants listed here, there are also about 100 plants, big, large hydropower plants of this utility, all monitored and controlled from these 6 remote centers. And the remote centers are also connected to the grid operator in Italy, and the grid operator is able to dispatch them in real time if this is necessary. The geothermal part, all geothermal plants are monitored into one single system, which is dedicated for geothermal generation. And there is one disaster recovery control center here ready at any time to take over any of the other 6 remote management centers in case of faults or malfunctions. Next, we can show an example from the US, where plants across all the US and some in Canada are all monitored into one big control center. It is about 93 renewable plants, again, different types, wind, solar, hydro, biomass, and geothermal here. It is a very large, as I mentioned before, we have a lot of data coming up into the system. We have 1 million points that the database has been typed for. And here we have the automatic generation control enabled and then being coordinated with different ISOs. As we can see, we have plants on the East Coast, we have plants in the middle of the US, and then we have on the West Coast. Similarly in Canada as well. So there are different ISOs in these regions, and the functionality of the system or the system itself is connected and linked to all of these ISOs. One of the interesting features of this example here, it is that the renewable management system is seen for the customer as a service in the cloud. That means that the system actually it is installed at ABB data centers, and ABB really manages the service and will be responsible for the maintenance of that system, for availability of that system, change management, and so on. Security of the platform, which is also a hot topic today to the generation utility. What the customer gets at his end, it's only the operator consoles. It has a control center where the clients are connected through a high-speed dedicated network to the server into ABB data centers. And from there, the operators are able to monitor, to control, and operate their plant. The third and the last examples that we have here is coming out from Spain and Portugal. Here again, around 100 wind farms are monitored. In addition to the AGC functionality here, which control the power production in different zones in Spain and Portugal, here we also have automatic voltage control functionality. And you may know that Spain has a fairly large amount of wind power installed, and that might be there the situation that there are windy days or windy nights, and the load might not be there to take on the power. And then it's really the grid operator of Spain asking actions on either AGC or AVC to really control power injections in different nodes of the network, such that, let's say, the congestions are not happening, and the corridors are freed from any congestions there. Again, the system is interfaced with two ISOs, or two transmission system operators in this case, one in Spain and one in Portugal. So basically, this is to give you an idea of how such a system, what sort of functions can it have, how these functions could help the operators, how it would help the owner of it to really make sense of what the data is out there, make sense of it, how to use it, and how to really plan to be performant on the market. So some of the key takeaways for you here today is really to understand that the real-time monitoring system, it's one way of reducing the cost of operating the generation asset. And then performance of this can really be improved by having the right features into the system, having the right visualization techniques, having the right alarm management system, setting it up correctly, the alarm management system, in the right way the operators are used to operate, to work with it, and so on. And of course, management solution, energy management solution, it's something where it's a trend to get more value out of such functionality, to really control the plants in a manner that the benefits and the power production is maximized, or even the profit is maximized in case you want to go on the market itself. And with that, I would conclude my part here, and I will be happy to take any questions.
Great. Thank you so much, Adrian and Dennis. That was a very informative presentation. And to everyone on the call, I really appreciate you attending. If you enjoyed today's webinar, I encourage you to consider viewing our other webinars in our WIN series. Like Dennis said earlier, we do have 4, and you can find out more information at www.abb.com/us. We will now open the webinar for questions and answers with our special guests and speakers. As a reminder, if you would like to ask a question during the webinar, or excuse me, during the event, please use the question box on the GoToWebinar panel. We will answer as many questions as possible. And Dennis McKinley will be asking the questions to Adrian. So Dennis?
Thanks, Katie. Adrian, great job. I was pretty excited to sit through the webinar here and hear about some of the different topics that you covered in pretty good detail. But the neatest thing for me was just seeing some of the use cases at the end where you're actually showing these systems are out there and being deployed as we speak. So very good job on that. We've got a few questions in, and again, just a reminder to the crowd, if you have a question that you'd like to ask, just go ahead and submit it. We'll get to all these as we can. First one up for you, Adrian. Excuse me. Is a real-time system really necessary, and why?
Yes, I mean, we've seen here, or what we've seen out in the market, there are some entities or some utilities, some owners using a real-time system, some others may not using a real-time system. And basically, it all comes down on how efficient you really want to be at the end of the day. Because there are things that you could do with a non-real-time system, and it depends on the data dynamics coming out of the plant, and depends on the rate of updating the data into the remote management system. But when it comes down to really be effective, being very responsive to what is happening in the plant, having automated solutions that you move data from the diagnostic functions into the energy management functions and so on, then really a real-time system is what you will need.
Okay, thank you. Next question, how does the ABB monitoring function work for an operator responsible to an ISO for multiple assets with only the ABB assets addressed through the ABB control system? That's a mouthful right there. Did you get all that?
Yes, I think so. I think so. Well, usually when we see this monitoring system here, we are interconnecting plants, and we are interconnecting technology from different OEMs, from different wind turbine vendors out there. Even though the control system is from ABB, what is underneath, it's coming from different owners and manufacturers. And what we put up there, it is into a common way of working with the system, and this is done at the remote control level. And of course, the interaction from that monitoring system to ISOs, to TSOs, to the market, this is done through the standardized way, for grid management, telecontrol, or file exchange information with ISOs for market planning and so on. This is nothing else or nothing more different than what is done today in the thermal world or in the nuclear world and so on. We are using the same channels and the same connections from the remote renewable systems to these entities, being the market operator, being the grid operators, or ISO altogether. I hope this answered the question, or I hope I got it right.
Yeah, so that was good. So just to paraphrase then, basically what you just said was it doesn't have to be all ABB assets on the wind farm or on the hydro or geothermal or what have you. We can find ways to connect all the different assets out there, regardless of whether it's ABB or not.
Exactly. It doesn't matter whether at the plant level it's ABB, or at the grid level or ISO level. The interfaces are there established. It is just putting them all together.
Okay, very good. All right, what is the more common operating mode, voltage control or power factor control?
Well, that really depends on the area where it operates and where the plant operates and so on. What we see in Europe, it is that the power factor control it is requested to be primarily the control mode for reactive power, which means that every time the active power changes and so on, the reactive power will change as well. Right? Depends also on the plant sizes. It depends where is it installed. We have some plants at the distribution level, particularly when we are talking about the photovoltaic plants here or solar plants. But usually at the transmission level and so on, then also voltage control can be requested. But again, really depends on the way the TSO is used to manage that grid, whether it wants to let the plant itself to operate on closed-loop voltage control at its connection point, or wants simply to not be so intrusive into the power system and then have a power factor control. It's difficult to say and to generalize it, but it is zone-specific, TSO-specific, and also a little bit of voltage levels specific, being in the transmission system or in the distribution system.
Okay. Next question. In addition to real-time view of plants, is historical data maintained? Performance reporting was mentioned irrespective of IEC 64100-12. Are downtime events captured, and is lost time and energy tracked and available for plant performance reporting?
Sorry, this I didn't get it. So what is the real question?
Well, I think what the real question, I'm just reading it over again, really what the question is asked is historical data maintained so that you can go back and look at events that happened in the past, capture that information, lost time, etc.
Yes, of course, the historical data is maintained. Irrespective by having the global control center or not. But one of the example in the U.S., we have the requirements to hold the data into the remote control center itself for a period of 6 years, such that data analysis can be done at that center only, or also at that center and not moved up into the control or the global control center. We see customers having different requirements from that. Some of them think, well, we have data here for 10 years. Actually, we don't know what to do with it. We can do calculations on the performance and see how everything degraded along the lifetime, but it's also a very huge amount of work to do that in a proper way. Having data is nice, but really, then if you want to do something with the data, you have to invest time, you have to invest money to find out how your asset has been evolving in the last 1 year, 5 years, 10 years. But typically, yes, we do have the historian part in the remote control centers where we can hold data for a large amount of years, depending on customer requirements.
Okay, very good. All right, what are the main challenges today on wind power forecasting, and will these changes affect the business case for renewables to participate in the energy and ancillary services markets?
Yeah, this is a good question. Of course, I have discussed a little bit about forecasting, but not its relations to the business aspect and so on. I mean, today, if we look at the market solutions, I think that we are very good at having a day-ahead forecast, and of course also intraday forecast, because with closer you're coming to real time, the easier it is to forecast there. One of the challenges is to go beyond 4 days and have really a good accuracy, an accuracy that is not rising your risk level very high, right? But apart from the long horizon, another key point for forecasting it is the ramp rate. Of course, aggregation at the fleet level it makes things easier, but really at the nodal level, there is something that we need to invest more. We need to find out the right technologies to better predict the forecast on the nodal level. And this is also why, for instance, in the example in Spain, the automatic voltage control was requested, and because really in some of the nodes we could have the south of Spain, it's quite windy, and then we could have a very high penetration of wind power out there, and the voltage can increase drastically. And this, if it was wrong forecasted or the forecasting error was fairly high, then it would have been impossible for the grid operator to allocate resource in other parts of the grid and move them down to south of Spain. So we need also functionalities across the geography to work out this. But ramp rates, it's another key point for forecasting where more investigation is necessary and find out the right solutions. Because otherwise everything will be moved into the reserves in the grid, and it will keep up and renewables as a costly generation technology.
Okay, very good. All right, I'll take this one on. What are the typical costs of the systems? And not to give a cute answer, but I got to state it depends. It depends on the size, depends on geographical layout, distribution, et cetera. But to the gentleman that asked that question, we'll get somebody back in touch with you, and we can figure out what you're looking for, and we can put some estimates together, working on that together. The next question, which I'll take on as well, when will the job of maintaining wind farms be covered, from basically the electrical functions covered today to the mechanical aspects of the turbines themselves? To the gentleman that asked that, again, ABB is primarily a electrical, power and automation company, so we don't really get engaged in the mechanical side of that at all. But I can bring that up with some of the folks at OE and some other industry groups and see if there's some available there. I do know that there's some operations and maintenance seminars and webinars that have been going on here in the last couple of months that you might want to participate in. But if you want further information on that, if you wouldn't mind, just send us an email and I'll get that out to you. Okay, another question for Adrian. Regarding diagnostics of plant data, what trends do you see out there in the market?
Yeah, this probably goes in line with the previous question, and it's, of course, I mentioned here, making a lot of sense or making a lot of value out of the data that you have there in the database. And the KPIs and standardized efficiency measurement or efficient calculations, it's state of the art today. But really taking that data, putting that data into the process models or making a wind turbine model and try to identify how the asset state, how the asset health is changing over time and so on. This is something, again, that we see as trends into this area now. And some of the utility or owners ultimately go and install even more sensors out there into the plants to get more to know about their assets. Because we have to see also that not all of the OEMs are providing really a lot of information out of this data, even though there are, as I mentioned before, 200 data points out there. Maybe only 10, 15 are relevant for your calculations. The others are just some digital values out there. So we see a trend really try to squeeze more intelligence, more value out of the data there. If the data is not there, try to put more sensors out in the field to understand better what is happening in the process, how can further the process be improved.
Okay. All right. Apart from the effective management system, and maybe before I start this is the last question I have out there, folks. So if you've got another question that you'd like to ask, please send it in. But I'll read this one here to you. Apart from the effective management system and intelligent energy management, what other technology system do you see applicable to improve the efficiency of the existing assets?
Yeah, I mean, of course, this is what the topic of today was about the remote management system. But of course, there are different other ways of improving the performance of the plant. If we come back to what I said before, putting out more sensors out there in the field is one thing is putting out systems, condition monitoring systems, or putting better sensors out there in the field. Now, there are a lot of discussions about having LiDAR technologies, so light detection and ranging, for measuring the wind speed, getting a better information about how the wind is hitting the turbines, how much can you improve at the turbine level, and how much can be improved at the plant level, and how much can be improved at the remote control level from this information. We have sonic sensors which place in front of the turbines, try to better align the turbines into the wind, try to improve the efficiency of power production all along the chain, the production chain. These are just a couple of examples what sort of other technologies could be used out there into the turbines. Of course, then we say at the plant level, the wind farms, to take an example, but it's the same as for photovoltaic plants. The production of, in particular, the capability of the inverters, particularly in wind turbines, we are discussing here about a full-scale converter technology. The capability of the plant to provide reactive power, it is directly dependent on the voltage at the converter terminal. And having a system unified to manage both the generation part of the plant, meaning the wind farm, and managing the substation part or the electrical balance of system, then you could play with the voltage level in the plant such that you have yet another degree of freedom to provide more or less or play with your capabilities to provide reactive power. And this is something, again, that could be put out there for grid operators to be used in case of emergency. So really, in integration of controls at the plant, it's also another key point.
Okay, very good. Thank you, Adrian. And I apologize, we're at the end of our time here, but I appreciate you folks sticking with us. Before everybody checks out, I'd like to turn it over to Katie. She can give you a couple of closing comments on how to close out of this, how to get additional information, et cetera. So take it away, Katie.
Thanks, Dennis, and thank you, Adrian. This is the conclusion of our webinar. When you all close out of the screen, you'll see a short survey of today's event. We really appreciate your feedback and comments on the webinar, and that helps us improve webinars in the future. You can see all 4 webinars in this series at abb.com/us, and also keep checking back for updates on future wind webinars with experts we'll have. So thank you all very much, and have a great day.